Now let's see one more example of an inverse of a function. This time we are going to consider the cubic function f3, which assigns elements, the real numbers, to real numbers, and each x is assigned to f of 3 of x, which is an abbreviation for x cubed. Now, look at this function. The graph is found here, so it's an always increasing function. It intercepts the horizontal axis and the vertical axis at exactly just one point, given by 0. When x is negative, this curve is always below the horizontal axis, and for x positive, it's always above. This means that the function is bijective. Look at the graph. Every single element on the vertical axis has a corresponding and unique x on the horizontal axis. So the function is surjective. Moreover, every distinct x that you choose is assigned to a distinct y, and so the function is one-to-one. As a result, it is bijective. As a consequence, there exists an inverse function for f3, the cubic function. By definition, that cubic function is as follows. F minus 3 maps the real numbers here into the real numbers here. How does this map work? Well, by definition, every element y is assigned to f3 minus 1 of y. And that number here is what? Do you remember? It is the solution x of x cubed is equal to y. So this tells us that every single time you choose a y, and you want to evaluate the image of that y under this inverse function, well, what is in fact being asked is solve this equation for a given y. Let's see some examples. If you assume that y, so y is equal, for example, to 8, then f minus 1, 3 of 8 requires us to solve the equation, let me write it, x cubed is equal to 8. Now we use a three-step procedure that we have previously. You first analyze the question at end, x cubed is equal to 8. You know that x lives on the entire horizontal line, so it can take any real number. And now we try to guess the answer. So for example, is x equal to 0? If you substitute 0 here, you get 0 cubed, but then you get 0 equal to 8, which is a false statement. So x equal to 0 cannot be a solution of this thing. Let's try again. Another guess. What if x is equal to 1? 1 cubed is what? Is 1. And 1 is different from 8. So again, a failed guess. What about x is equal to 2? 2 times 2 is 4, and 4 times 2 is 8. So when x is equal to 2, you have indeed the correct answer. So we can conclude that this number here is in fact 2. We just found one of the associations, one of the mappings that is done by this function. More, let's try another one. What if y is equal to 27? Let me make it harder. Minus 27. F minus 1 of 3 of minus 27. What sort of number is this? Well, again, we set up the question properly because this is our definition. This thing here is an abbreviation for solution x of x cubed is equal to minus 27. And now we have this problem at end to solve. And in general, we already know that we have a three-step recipe to attack this sort of problems. We analyze the question. We know what it means to cube something. You know that x lives on the horizontal axis, so it's any real number. So what sort of thing could possibly be mapped into minus 27? Well, let's guess it. Well, if it was 3, for example, we already done for 2. 2 cubed is 8. What about x is equal to 3? Let me write it. If x is equal to 3, that means that 3 cubed is 27, not minus 27. But however, if you consider minus 3, What if x is minus 3? Now you can see minus 3 cubes is 27, minus 27. So indeed, this number here is minus 3. Notice that what is the formula? What is the formula for this thing? You see, on the previous example that we saw, we actually got the formula for the inverse function. This time we do not have a formula. And we won't have a formula, okay? For now, this is the only strategy that we have to evaluate this inverse function. You just guess the thing, and that can only be done for very basic examples, for very basic y's, okay? Those y's that we can cube mentally. For other numbers, we probably need to use the computer to give us an approximation. So there is a lot more to say about this thing, because we don't actually have a formula for this thing, but for that, more on that later.